video looks at Chapter 3, Methods of Calculus, and it's the questions on inverse trig functions. You'll see from the standard results that are given at the top of the page that we are both differentiating and integrating. Now, these results are given to you in the formula book, so for further maths, often you will just use the results, but you also need to be able to derive them. So we shall look in this video at the differentiation. We shall derive the results which you met in A2 Maths. So we'll go through that as a reminder, and then we will do question 1 showing the use of the results and chain rule. So I'm going to have a look at the first result here, the arc sine one we've got here, and we're going to remind ourselves how to derive it. So we have y equals arc sine of x. So dealing with the arc sine, we can write sine y equal to x. And then I'm going to differentiate that, and I'm going to do it by using implicit differentiation. So sine y differentiates to cos y, but I'm differentiating with respect to x, so I need dy by dx, and x differentiates to 1. I then rearrange to get dy by dx, which is 1 over cos y. So I've got my result, but I've got it in terms of y. So now I need to have that result in terms of x. So I'm going to replace cos y using a trig identity and the fact that x is equal to sine y. So dy by dx equals 1 over the square root of 1 minus sine squared y, which is 1 over square root of 1 minus x squared. Hence we have arrived at the result. So I did that using implicit. So this one here is implicit differentiation. I could also use the inverse rule. So I could start slightly differently. So we'll have a second example here just to show you the beginning. We'll have that's number 1 and this is number 2. So I've got sine y equal to x, differentiating cos y equals dx by dy. So I was differentiating with respect to y. I can then reciprocal the relationship, so I will get dy by dx equals 1 over cos y, and then I would carry on in the same way that I did from here, using the identity to arrive at my result. So we've got implicit here, and we've got using the reciprocal or inverse rule for differentiation. So that's deriving, which you may be asked to do in further, but you're more likely to be asked to do in maths. Now, question 1 asks us to find dy by dx for this function. So what we're going to do is we're going to use the result that we've got here for the arc cos part, but we've obviously got 3x squared minus 1 sitting inside the arc cos. So we're going to use the chain rule. Let's do it formally. Y equals r cos of 3x squared minus 1. So the function sitting inside is 3x squared minus 1. So we'll let u equal 3x squared minus 1 du by dx equals 6x. So my function is now y equals the inverse cos of u. So dy by du equals, using my rule from the top of the page, it's this result here. So it's minus 1 over the square root of 1 minus u squared. Now, chain rule, just a reminder, dy by dx equals dy by du times by du by dx. So I'm going to multiply this and this together. Dy by dx equals minus 1 over the square root of 1 minus u squared times by 6x. And now I'm just tidying it up algebraically. So I've got minus 6x over square root of 1 minus my u, which is 3x squared minus 1. And I can obviously tidy up the bottom. Sorry, I forgot my square there. Squared on there. I could tidy up the bottom further, but I don't need to. I've reached a result there. Because I've got the squared, they're not looking for you to undertake algebraic simplification down here. So that's using the result, and as you can see, I've done it formally with the chain rule. You could do it more intuitively by knowing that the differential of what is inside the inverse trig will appear here, having multiplied, and then this is the result from the formula book with the 3x squared minus 1 in. Okay, so that's an introduction to inverse trig and its differentiation using the standard results.